Okay, year 11. We're going to look at circles and semicircles in this lesson. Now, first of all, circles are not functions. Okay, so why aren't they functions? Well, they've got to pass the vertical line test for starters. And we know that if I draw a vertical line on any circle, right, let's draw a circle there. You can put your axes in there as well. If I draw a vertical line, let's do a different color. Okay, vertical line anywhere you like, you're always going to get a line which has two intersection points with a circle. And therefore it fails the vertical line test, therefore it's not a function. Okay, now the equation of a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. Now, easiest way to prove this result is to draw a circle with center the origin. You put a point on the circle, there it is. There's my point. Any point, let's call it P. Okay, so P is that orange point there. You got the center, the origin there. Now, just using Pythagoras' theorem, I can write down x squared plus y squared equals r squared. Okay. The other way you could have done it is you could have used the distance formula. You could have said that the distance r, okay, so r is the distance of, now that's xy, and then there's 0, 0 there for the origin. You could have also gone x minus 0 all squared plus y minus 0 all squared. Okay, and that will just simplify to, that's r there, not a square root, r. So I'll just try that again. So r equals the square root of x squared plus y squared. Okay, and then square both sides. So square that side, square that side. That leaves me with r squared equals x squared plus y squared. So there's my equation. So you can either use Pythagoras' theorem or you could use the distance formula to show that for any circle, x squared plus y squared is equal to r squared. It's the relationship between x, y, and the radius. Okay. Let's have a look at our first example. We've got to sketch the graph of x squared plus y squared equals 4. So let's do that. Okay, so now we know that the equation for a circle is x squared plus y squared equals r squared. Okay, so the r squared is equal to 4, which means the radius is equal to 2. All right, and we know that the center of the circle for this equation is 0, 0, so put a little dot at the origin. And then the radius is 2. That means I'm just going to put a radius of 2. So I'm going to use 4 points to draw my circle. And then starting from here, and then, okay, there's my best circle. All right, you're doing it by freehand, so it's not going to look perfect. And you've got a radius there of 2, don't you? So technically, there's a radius. And that should be 2 units, whichever way you go about it. So that's the first one. Now it says, why is it not a function? Well, we answered that before. I'd say the circle fails the vertical line test. Okay. Status, domain, and range. Well, you can see for the domain, let's write this down in 2 ways. The domain would be between -2 and 2. Okay. Or you could say, you could write it like this, from -2 to 2. The range, okay, you could write it the same way, but this time it's the y values, 2 -2, and or you could write it like this, the same way as before, -2, 2. Okay. Now let's have a look at next question. Write the equation of a circle with radius 3 and centre the origin. Okay, so radius 3 and centre the origin. That is going to be, well, we know that it's x squared plus y squared equals r squared. R squared is 3 squared. So in other words, x squared plus y squared equals 9. Okay, next question. What about a circle with centre AB? So what if it's not the origin? Okay, so here we have a circle with centre AB. The equation of the circle with centre AB and radius r is this: x minus a all squared plus y minus b all squared equals r squared. Okay, now to do this, we're just going to use a distance formula. So the distance between PQ, if you like, which is the radius of the circle. So the radius of the circle, the distance between the centre and the point PXY. So you're going to have x minus a all squared plus y minus b all squared. Okay, and then you're going to square both sides. So let's do that. 2 and 2. So it gives me r squared is equal to x minus a all squared, there's an a there, plus y minus b all squared. Okay, let me just tidy up that last little bit there. Okay, x minus a. Okay, now that's the formula for equation with a centre AB, radius r. Now, if you've forgotten what the distance formula is, remember you've got to label your values for your points. x1, and this b here, that would be y1, and then this is my second y value, and the x here is my second x value. Okay, and remember the distance formula says d is equal to brackets x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so that's the formula that I use for the proof. All right, this one here. Now, just to show you that in action, let's have a look at a GeoGebra applet. So let's just open that. Okay, so have a look. If I change the radius of my circle, there we go. Let's move that down a bit. You can see the radius changing, can't you? So let me just change it up to here. Yep. You can see as my radius changes. All right, so here I've got a radius of 4 units, and you can see it's, and the center is 2, 2. So x minus 2 squared plus y minus 2 squared equals 16. I've got a radius of 5, so the equation changes again. Now what if I change my center? So let's move the circle down a bit. Okay, how about at 2 minus 1? Now 2 minus 1, I'll just change my radius again. Okay, so you can see that the equation now is x minus 2 all squared plus y plus 1 all squared equals 9. The radius is 3 units now. Let's change the radius to 2 units. You can see that I've got radius of 2, so the equation is x minus 2 all squared plus y plus 1 all squared equals 4. And if I take my circle back to the origin, have a look how the equation changes now as I change my radius. Okay, so you can have a play around with that applet. There's a link on the PDF file. Okay, now let's go back to our notes. Okay, so sketch the graph of this circle, x minus 1 squared plus y plus 2 squared equals 4. Now, let's think about this. I think my pen just fell. Here we go. All right, so let's just change the thickness. All right, so I've got this equation here. So this, actually, I've just realised that the formatting there is not correct. That should be x minus 1 squared plus y plus 2 squared equals 4. All right, you can see these 2's didn't get formatted properly. Okay, now let's write down the formula for the equation of the circle. Okay, equals r squared. All right, now you can see that these two don't quite match. There's a plus and there's a minus sign, but we can write the equation so it matches the formula. So I'm going to write the plus 2 as minus negative 2 equals, and the r squared, I'm just going to write that as 2 squared because 2 squared is 4. So you can see that the centre of the circle is 1 comma minus 2, and the radius is equal to 2. All right. Now the way that I think about finding the centre of the shortcut is I just think of which x value do I have to put into that equation to get 0 inside the brackets? Well, that's 1. What y value do I have to put into the brackets to get 0? And it's minus 2. That's a quick way of working out what the centre should be. And the radius will always just be the square root of the constant term. So here, because r squared is 4, okay, if you square root both sides, you get r is equal to 2. Okay, so let's plot that on the number plane. So 1 minus 2, that's down here. And now the radius is 2, so I'm just going to count 2 units to the right and 2 units to the left of the centre. Okay, 1, 2. And 2 units up from the centre, and then 2 units down from the centre. And that'll help me draw the circle. So okay, there we go. There's my circle. Okay, and the radius of that is 2 units, isn't it? Yep. Okay. So let's have a look at the next question. All right, so the next question says find the equation of a circle with radius 3 and centre minus 2, 1. Okay, so let's see how we're going to do that. We're going to use a formula again. Now remember the formula is x minus a all squared plus y minus b all squared is equal to r squared. So now this is my a value and this is my b value. So I'm going to get x minus negative 2 all squared plus y minus 1 all squared equals, radius tells me is 3, so that's your r value there, so 3 squared. Okay, so I can tidy it up a little bit. The 2 minuses become a plus, so we get x plus 2 all squared plus y minus 1 all squared is equal to 9. So there's your equation. All right, next question is find the centre and radius of this circle. Okay, now this is not in the form that we recognise, but we can fix that by completing the square. Okay, so we are going to complete the square on that expression. So let's do that. So I'm going to get x plus, now I'm going to half the coefficient of the x term to get 1, and I'm going to square that. Now, if I expanded x plus 1 all squared, I would have this x squared plus 2x plus 2. Now, I have the x squared, I have the 2x in the equation, but I don't have the plus 2, so I've got to compensate for that by subtracting 2. Okay, then plus, now it'll be y, half the coefficient of -6 is -3, and I'm going to square that. And again, if I expand y minus 3 all squared, I'm going to end up with an extra term, which is +9. So I've got to subtract the 9 there. Okay. Then on the end, I have -6, the constant term, and then equal to 0. Okay. So I can tidy that up now. I'm going to get x plus 1 all squared plus y minus 3 all squared. Now the constants, -2, -9 is -11, -6 is -17, equal to 0. And that gives me x plus 1 all squared plus y minus 3 all squared is equal to 17. So the centre of the circle, let's write that down. So that means centre is -1, 3, and the radius is the square root of 17. Because remember, this here is r squared. Okay, so if r squared is 17, r is root 17. Okay, that's that question done. Now, just realised I made a mistake on that one, didn't I? Okay, let's see where we can figure out the mistake. Over here. Okay, here. That should be a 1 there, shouldn't it? I'll just fix that up. So let's change that colour. Okay. Yep, there should be a +1 there. And that means this guy over here, scribble that out, that should be -1. Okay, so let's just fix that up. Get rid of that. That should be -1 there. Rest is correct. -1, -10, -16 that should be then. So here, that should be -16. And that means over here, that should be +16. That's better. And then here, we're going to have radius to be 4 units. Okay, because if r squared equals 16, then r must be 4. Okay, so just made that mistake there. So fix up your notes there. All right, now, next question. Find the centre and radius of the following circles. Okay, so the centre and radius of this circle. So you can pause the video if you want to have a go at this. Centre equals radius equals. Okay, so centre is 813. Oops, just tidied that up a bit. And the radius is 5, isn't it? Right, because we know that this here is r squared, isn't it? So if r squared is 25, r is 5. Over here, we're going to have the centre equal to -2, 7. All right, the radius is equal to √3. Okay, because remember that there is equal to r squared, so that means r must be root 3. All right, what about these down here? Write an equation for the circles below. So you can see here what the centre is. Let's work out the centre. Centre is negative 1, 2. Negative 1, 2. The radius, let's work that out, goes from here to here. Count how many units? 1, 2, 3. The radius is 3. So r equals 3. So our equation will be x plus 1 all squared plus y minus 2 all squared is equal to 3 squared. All right, now if you're wondering where the plus sign came from, remember the equation is x minus the x coordinate of the centre, which is minus 1. We could write 9 there instead. And those two minuses become the plus. Okay, over here, our centre is 1, 2. The radius is 1, 2, 3, 4 units. So we're going to have x minus 1 all squared plus y minus 2 all squared equals 4 squared, or we could just write it like this. Okay, I'll copy that down. Let's just see if we've answered all the questions. Okay, not quite. If you come back up to here, you can see it wants an expanded form. Okay, so what we're going to do then is just expand the brackets. So x squared plus 4x plus 4, that's the first bracket expanded. And then plus y squared minus 2y plus 1 equals 9. Okay, and then we can tidy that up a little bit, can't we? We can write that as x squared plus 4x plus y squared minus 2y, and then we can have the constants there. 4 plus 1 is 5, and if I take the 9 over the other side, I'm going to get minus 4, aren't I? So I can write this as minus 4 equals 0. Okay, so that's an expanded form. So that's all the circle questions done. Okay, now what about semicircles? Now, the equation x squared plus y squared equals r squared is a circle with centre of the origin and radius r. It consists of two semicircles. And to find the equation of semicircles, we need to make y the subject. So let's have a look here. I'm just going to make y the subject. So start off with y squared equals r squared minus x squared. And then take the square root of both sides. Make sure you do plus or minus. Okay, so we have two equations. We have the positive equation, the one with the positive in front of the square root. And we also have the negative equation. Okay, so now the positive equation will be the top part of the circle. Okay, so the top half of the circle will be the positive. Why is that? Because above the x-axis, the top half of the circle there is where the y values are 0 or positive. Now, the bottom half of the circle, let's have a look at that. The bottom half of the circle, so that is this part here. and that is the negative part of the circle. There we go. All right, done. Okay, so let's have a look at the conclusion then. The conclusion is we've got two semicircles which make up the circle. Here's the top equation, the equation for the top half, and here's the equation for the bottom half. Okay. Now, next question. Equation of a semicircle with centre 0, 0. The equation, so here's our little summary then of those two equations with centre 0, 0 and radius r. So let's have a look at our questions here. Now sketch the graph of each function and state the domain and range. Okay, so this will have a radius of 3, won't it? So think about it. This is of the form y equals the square root of 9 minus x squared, and that 9 there is the radius squared, isn't it? So we can say r squared is equal to 9, r is equal to 3. Okay, so that radius is got derived from the 9. There is positive as well. This is a positive, the square root has got a positive sign in front of it. So centre 0, 0, radius is 3, so put a dot there, and dot here. And then we draw our semicircle in. There we go. So there's your semicircle. What about over here? We've got this equation is of the form y equals minus. Here's the form of the equation. So clearly r squared is 4. Okay, so r squared equals 4, so r is equal to 2. So radius of 2. Now it's got a negative sign in front of it, which means it's the bottom part of the circle. Okay. Not too bad. This should be just getting vertical there. And yeah, that's better. Okay. So there's your two circles. And it says state the domain and range. Well, domain, let's have a look. Domain, two ways of writing it down. It's between 3 and minus 3. Right? Or you could write it like this. Minus 3, 3. And the range, two ways you can write that down. Minus, it's actually between 0 and 3, isn't it? The range, if you look at the y values go from 0 to 3. So 0 less equal to y less equal to 3. Or you could write it like this. 0, 3. Okay, what about over here? We could say the domain, right, first it's between minus 2 and 2, so that's how you write it down with the single inequality expression, or you could write it as this, minus 2, 2. And then the range is between 0 and minus 2, isn't it? So minus 2 is equal to y. Yep, that's equal to y. It's equal to 0. Or you can write it like this. So minus 2. Minus 2 to 0 inclusive. There we go. Smaller number first. Okay, so that's domain and range. And that is it. So now you can start exercise 503. So just make sure all of this is copied down. Everything that is annotated on here. We've answered all the questions. Yep, all questions answered. Yep, including that correction. Make sure you've made that correction down here. And that's it.